Welcome everyone. So pleased to have you join us today. I'm Dr. Glenn Strauss, and I'm joined by a wonderful panel today that we'll get you to know a little bit later in just a few minutes. This is a special thanks to all of you for joining us, and a thanks to Orbis for making this possible and setting this all up, and all that behind the scenes work that goes on. That's very real, I can assure you. And so much appreciation to their team for making this all possible. Just a couple of housekeeping notes from my side. Just remember, our panel will be interacting together. And so you'll hear more a conversation than a presentation. And that's by design. That's what we really want you to hear today, is not just a presentation of information, but kind of the heart behind that, the feeling behind that. Where are we going with this, and some of the priorities and issues that we each face. But I also want you to remember that we can't see you. So we can see each other, but can't see you. So there's a provision for you to be able to interact with us in different ways. I'll be asking for your input along the way as we're conversing. You'll be able to use your Q&A button for that. But we'll also be asking for you to participate in some other ways too, as we get going. So to help you get to know us a little bit, let me just ask our panelists if they would introduce themselves. By the way, this is an amazing panel in that they have such a breadth of experience and depth of experience in this. So I'm really honored to sit in the chair that I'm in to moderate this discussion. I think we will all learn a lot, myself included. So, Jacqueline, perhaps we could start with you, please. Just a little bit about yourself and your interest in this field.
Sure, yes. My name is Jacqueline Hugstall, and I am an ophthalmologist and cataract surgeon at the University of Iowa. And a couple of my roles there, I'm the associate program director for the residency program and the director of ophthalmic simulation. I've also for years been the dedicated instructor for our wet lab curriculum that is available online, where I teach the basics of cataract surgery and some intraocular surgery one-on-one with our beginning residents. And we use various types of simulations. I kind of have a strong interest in surgical skill development and how we can best train our residents to become really strong, confident, and safe surgeons, and without placing a lot of extra risk on the patient. So we want to feel like they're really safe before we put them in that situation where they're starting to operate. We also we built and designed a simulation lab in our facility, and it's dramatically improved our ability to overcome some of the perceived barriers to simulation, such as like lack of space and having the equipment available and stuff like that. But it's still, the design took a lot of work and comes with some decent costs and stuff like that, and which not everyone has available to. And so I have placed a lot of thought into how can we make simulation more accessible, and how can we make more specifically for us, but I think is applicable to others, like how can we make this space not only available, but useful? And so much of my time I now spend kind of designing curriculums for independent practice, and how I can use simulation and simulation models or eye models in this teaching process to help train the next generation of surgeons.
Fantastic. Thank you. Natalia, would you share a bit about yourself and your background?
Thank you. So firstly, I would just like to very much thank you for the invitation to participate in this discussion. It's a real honor. My name is Natalia Ronatovic, and I am a client success manager at Fundamental VR. We specialize in the development of virtual and mixed reality simulations for medical education and the healthcare industry. And I've been working very closely with Orbis for over 20 months, almost 2 years now, on very small incision cataract virtual reality simulation program. And it's been a very interesting and exciting journey so far.
Thank you. John, Dr. Ferris, about yourself, please.
Glenn, again, thank you very much to Orbis for the invitation. I'm a cataract and pediatric ophthalmologist in the UK. I've been involved in training all my career, really, for 25 years. I was the Royal College of Ophthalmologists surgical skills lead for 6 years, and I've had the great honor and pleasure of working with Orbis in a number of ways. One, as a volunteer faculty in Trujillo in northern Peru and Santiago. I'm also now a trustee of Orbis UK, and as well as championing, simulation. We've now some simulation training is now mandatory in the UK before you do any part of a cataract operation, and that's a mixture of virtual reality, but also models as well. And during COVID, along with many others around the globe, COVID actually has helped training, because it's made us realize that you can actually provide great training to people around the world without actually hopping on a plane. And although we love going to different parts of the world, it's actually better for the planet and much better for the trainees if we can provide them with training from home. And the webinar, the Orbis Symposium we just conducted on Monday, ESCRS, on democratizing cataract surgery training, showcased a lot of those methods, and we'll be talking about those in more depth, no doubt, as we go along. But I just want to say at the outset, I think one of the mantras it should be that it doesn't have to be high tech, it doesn't have to be expensive. The two technologies work together, and a lot of great things can be done with cheap model eyes, which are highly effective ways of training, and we'll explore those, no doubt, as we go on.
Yes, indeed. Thank you. Well, I think you can all hear from what has been said already why this is a very good panel that will bring some good information to light. Myself, I'm an ophthalmologist also. I was in residency training with the residency director at University of Texas, and then stayed involved in training pretty much my whole career. Also got involved in international training in 2004, and have been involved in international training ever since. Left my practice here to do so. So I was just realizing not too long ago, it's been about 45 institutions that I've worked in some 38, 39 countries, which I thought, how did I do that? I was this sort of this stunning thought that somehow that happened. But to me, the exciting thing about that is that I have seen from sort of a 30,000-foot view these issues that we'll be talking about today. Why is this an issue for all of us? What is it that sort of bonds us together as colleagues in ophthalmology and in training to make this an issue that we need to discuss even? And so I hope some of those things that create kind of a common interest and a common need will become clear as we discuss these things today. And I really hope that our discussion will challenge all of you in the audience to think about what role you might have in the development of training in ophthalmology. Skills training in ophthalmology is an important issue for us all. As Jacqueline even said, I think she said it very nicely, that her concern is, how do we keep this going forward? The need in the world is not getting less, it's getting more. But how we deliver that skill training is going to be changing. There's no question about that. And how do we take advantage of the opportunities that we have now? I'd like to say that the things we talk about today, the technologies that we talk about, technology doesn't train people. I've said that over and over again in presentations and in different venues. And I hope that takes a little bit of or sets a little bit of the perspective here. This is not about how technology is the solution to everything. Rather, people train people, and it's how do we use the tools that we have available to us to really impact the need that we face. And I hope that you will all, again, benefit from the discussion that we have and find ways that you can be a part of that solution as well. So we've gotten to know us a little bit. We'd like to get to know you a little bit. To do that, our host is going to post an audience poll that will help us so that we can know a little bit more about you. It's just 5 questions. They're just yes/no questions. If you take just a very quick look at that and answer very quickly to these. We'd take just a minute or two so that we can see how you kind of where the picture of what our audience is like today. I'm sure, considering what I saw, the list of those who registered, that there is quite a diversity, and it's that diversity that we want to see a bit of. So go ahead, if you would please begin and just answer these 5 questions for us, please. John, I was very interested in one of the things that you said about democratizing training. In some ways, that is a good thread that I think will help connect these questions that we have today, that we discussed together. In some ways, it really is about that. Jacqueline, you talked about autonomous learning, or independent learning, and it's the same thing. It's how do you democratize the training chain? How do you make training something that is accessible and useful to everyone, all of our colleagues? How do we do that? And I think it's going to be an important next generation issue. It's in our lap at the moment, I would say, but it's one of those things that is going to need a lot of attention as we go forward. Okay, let's see. Are we able to see the results of this now? So the first, just to look at these very quickly together, a little less than half actually provide, those who that in our audience so far today, a little less than half are actually involved in one-on-one live surgical training. Most people have experienced some barriers, which I'm not surprised to see that. 72% have experienced some barriers to training. Not quite as high a number as I thought of people who might have access to artificial or biological wet lab surgical training. Only 36%. That's an interesting one to me. I would have thought that might be a bit higher. Access to virtual reality surgical training, that's actually a little higher than I would have thought it to be. That's quite a pretty good number. 24% have consistent access to virtual reality surgical training. And 100% are interested. There you go. That's the right audience. We're here. We are off to a great start. All of you are interested, and I am too. And I know our panel is also. That's why we're here to discuss this together today. So let's get on with our panel discussion. And thank you for that, audience, for letting us get to know you a little bit that way. Shall we go ahead and get into our discussion questions then? The way I would like to do this, our panelists have seen these questions, but I'm going to pose the question and create kind of a framework in which I would like our discussion to proceed. Kind of what's the question about? Why is this an important question, sort of thing. So that'll be my job, is to try to create a framework around it. You, as the audience, also have the opportunity to participate by using the Q&A feature in your Zoom bar at the bottom. You can pose questions, give comments. We won't likely answer all of those. Probably won't be able to, and but we will make an effort at the end of each question that we discuss to look over maybe some themes that we hear in the questions, some things that we might be able to reflect to you, make sure that we're hitting topics that are relevant and useful to you as an audience. So for the first question, we all know that technology is rapidly advancing. That's very obvious. Everyone knows that. But how does this connect to the work of surgical training? We all know how it connects to the work of delivering surgery, the advances in phacoemulsification, the advances in glaucoma surgery, the advances in how even the microscopes operate, and the way that they enable us to visualize what we need to visualize. We're all familiar with that. But how might technology connect with the educational side of the work that we do? Let me just ask the audience a quick question to get us started on this. How many of you have been involved in surgical skills training for more than 10 years? Now, in our poll, it said that there was less than half that were involved in live face-to-face surgical training? This is a little bit of a different question. I'm trying to, by asking this question, I'd like to just get a quick idea of how long those who have been involved in surgical training have been involved. Those who have been involved for 10 years or more, if you would just go ahead and raise your hand and we can see those results quickly. I don't see the results at this point. Anybody seen the, there should be a list of attendees, the number of people who are, okay,
yeah, we've got.
It looks like there's 6 to 7.
Six. Yeah,
there were
6.
Oh, I see it. Yeah, the 154, about 7. So that's really useful to me because that means we have quite a few young skills trainer, people who are at an earlier stage in their careers that are listening and participating today. I think that's really important. The traditional methods that we've used for training, this, I started in 85, for goodness sakes. I mean, I go back quite a ways in the surgical skills training arena. They worked. I mean, it wasn't that they didn't work. There were good surgeons that came out of doing things in the traditional ways. But a new generation is very aware that new things can have better effects, can do things better. I think we've all likely experienced, if not for ourselves, but with those that we're working with, that it can be kind of painful. Sometimes the training process can be painfully slow. And the problem is that our institutions that we work in sometimes don't have the resources to deal with all of that. So my question, I would like, let's see, one last question. How many of you in the audience have worked in limited resource environments? This is a second issue. How many of you have worked in limited resource environments? Yes, just raise your hand if you have. Looks like 33.
Yeah. So about 20%.
Okay. So to me, it's another very important issue for us to discuss today. Our panelists have already mentioned their involvement in this in different ways. That there's, if we're talking about democratizing training, then we're talking about global democratization of training. We're not just talking about in one place. The whole point is we all get on the same page in terms of the skills development that is required, how we do that, and maybe in the process come up with some things that really work efficiently. So my first question I'd like to ask the panel today is about their experiences in the training arena and their initial thoughts on how learning technologies may or may not improve our training paradigms. So let's begin. I'm going to, maybe to help us get started with our discussion, I'll just call on you, not in no particular order, but just to help us get started. John, I'd like to start with you actually for this particular question. What do you see as the key challenges, perhaps, to improving the efficiency?
So one of the things to overcome, everybody in the panel here, and hopefully many people listening, are convinced of the benefits of simulation. And at ESCRS on Monday, in the arena, we had a debate, and the debate was, should simulation training be mandatory? And I had the easy job of being the team leader in that team, and the others who are opposing that didn't really believe it shouldn't be mandatory, but they had to put a debate forward. And one of the main drivers for this initially is enhancing patient safety, accelerated skill acquisition, objectively being able to assess somebody's competence before they operate on a patient. For more senior surgeons, adapting to new techniques and new technologies, and increasing the confidence and reducing the anxiety amongst trainees. Now, the evidence is there that simulation works. The huge study that we did in the UK was 17,000 cases done by first and second year residents, and looking at their PC rupture rate before the instigation of IC, virtual reality training, and afterwards, showed there was almost a 40% reduction in PC ruptures and complications for those trainees who had undergone this type of surgery. And the National Ophthalmology data set that collects details on every NHS cataract done every year has shown that PC ruptures for trainees has dropped in the last decade from 5 to just over 2%. So over a 50% drop since simulation was made mandatory. And that's a combination of the virtual reality and the model eyes. And when it comes to cost, that's an awful lot of cost saved to our NHS, never mind to the distress caused to patients. So that's one way of addressing the cost of this. But the other technologies that it's not so much the IC or the model eyes, but communication. Simple little STEMI microscopes that are used around Africa with the work Will Dean has done and the team in Cape Town means that with a very simple little microscope linked to your mobile phone, wired up to Zoom or to Teams, you can have access to trainers from anywhere around the world to provide the training. So the training that Jackie's providing in Iowa, which is one-to-one with her beside the trainee, that same quality of training can be provided to people at low cost in their place of work in very rural settings. And I think that's one of the very simple technologies that's improved. You can also, on your IC or the fundamental VR simulator, you can have a trainer remote to you, watching in real time your practice. And that's a tremendous advantage, because one of the barriers to simulation training is trainer's time and accessibility and being in the same place at the same time. We ran a Capsulorhexis workshop at the end of COVID with Uday Devgan, the cataract coach, in his office in Beverly Hills, and 4 of our trainees at home in their kitchens, living room studies with the microscopes, and he was teaching them how to do Capsulorhexis. And you can do that, and Will Dean does this a lot with his trainees in Kenya and Tanzania and Zim and Zimbabwe. That can all be done from the comfort of our own homes. So I'd really like to emphasize the importance of that technology. Orbis have shown in their studies, they've run entire cataract surgery training courses, 4-week courses, virtually, with the use of video links and video assessments. So the technology is there, not only with the simulation methods themselves, but also how to have high quality supervision to ensure that when trainees are practicing something, they're practicing it correctly. So we can make sure, no matter where you live in the world, you could have access to really high quality training at relatively low cost. And even if the simulators are based in one geographical area, people have to travel to them with the virtual reality side, that can still be linked into trainers from any part of the world. Those are the first points I'd like to make.
Thank you. Really good. If I could summarize, I'm learning here. So the things that simulation has are safety, efficacy, objectivity, adaptability, confidence building. Those were the 5 things that took as key points that you made. Is that summarized?
Yeah, exactly. And with Will's study, as you know, Glenn, so Will Dean, the 2 randomized control trials, and they're the first and only ones, RCTs, at any surgical specialty that have shown the benefits of simulation, run out of the Centre of Community Eye Health in Cape Town and Groote Schuur. He showed that not only for trabeculectomy, the GLASS study, for small incision cataract surgery, the Olympic study, showed that objective competence improved by 75% in those who'd undergone, or threefold rather, who'd undergone simulation training, and complications were reduced by 75%. It also doubled the number of cases they've done. So in both small incision cataract surgery and trabeculectomy, not using virtual reality, simple model eyes, apples, tomatoes, other things like that to start with, you can take a novice surgeon to become competent to commence live surgical training in a 2-week period, and it did not cost much at all. It works, and it doesn't have to be virtual reality for those whose budgets are tight. It can be done with very simple model eyes. And another interesting thing from that study was that the trainees taking part became very expert assessing their own surgery, because it was recorded and they would mark the surgery in a scoring matrix. So they could look at their own videos and be self-critical and mark themselves, and they could then tell when they'd reached a competent level without even having the trainers tell them that they could actually do that themselves, which gives more opportunities for self-directed learning when you can look at videos and score yourself and say, you know what, I'm ready to start doing this in patients now because I've achieved the competence on the scoring matrix, the validated scoring matrix. So that's an exciting avenue to explore as well.
It is indeed. Jacqueline, I'm going to come back to you in just a minute. I want to first ask Natalia about, it's almost a dream that everyone would have equal access to, the technologies that John was talking about, that provide adequate internet to, adequate bandwidth, to actually be able to run remote workshops. What are some of the things that you've seen and experienced in your, as you've worked with surgeons who are trying to employ some of these devices? I think back to our trials in Ethiopia, the FER trials in Ethiopia and some of the challenges there. I think about the Bangladesh trials and the challenges that were there. I mean, it's an enormous uphill effort to try to make it. Could you comment, please, just a bit about some of those experiences? What do you think are some of the barriers to achieving some of these things?
Sure, Dr. Strauss. So I think high quality and fidelity training tools such as these advanced simulators that are available in the Western and high resource countries, as Dr. Ferris said, they do enable students to build confidence and proficiency by practicing a surgical procedure in a very controlled and safe environment. But of course, these simulators are associated with high equipment costs, subscription fees, and they're not easily portable. So I think they're quite inaccessible to students and medical residents in remote and underserved areas. Now, what Orbis is doing in simulation is they're taking relatively cheap, off-the-shelf VR equipment that can be transported in a suitcase on a plane, and then they're donating this equipment to their partners in places such as Bangladesh, Mongolia, India, Ethiopia, as you mentioned. And although the simulation is maybe lower fidelity compared to the Help Me See or IC simulators, the Orbis simulator is unique in that it does not require the presence of a trainer, and the students can use the VR tool on their own in their own time and at their own pace. And once again, I think that's very just unique and gives them that ability to just practice a lot. And then the goal is to teach students the ABCs on the small incision cataract procedure so that then when they go into a wet lab or some classroom training, the instructors can skip the basics and focus on the more advanced training, thereby saving trainer time. And there's this little anecdote that I really like talking about, but when I joined the company and when I started working with Orbis, I knew nothing about ophthalmology, zero, and I don't have any medical background. And then for about 9 months, I worked very closely on the project, and I'm basically the middleman between Orbis and my company and all the engineers. So I oversee a lot of the development parts. And I learned the cataract procedure via the simulation, via you, Dr. Strauss, as well, and all your knowledge and contributions to this project. And then 9 months later, I was at AAO last year, and I had the opportunity to try Help Me See. I'm like, okay, of course, like this is a very advanced simulator. And I sat down, and I think I remember it was a paracentesis step, and I knew exactly what to do. And the trainer next to me, they were like, "Oh my God, very good technique. What year medical student are you in?" And I'm like, "Yes," like that's amazing. I of course wouldn't go ahead and do cataract surgery on a real human being. Absolutely not.
No.
But I think that just really showcases the ability, the potential that simulation has to provide that comprehensive overview of the problem in front of you. Yes. And then, Orbis integrate this simulation into a widening training curriculum that focuses on cataract, and then they can provide mentorship programs for cyber sight. So I think that Orbis is really doing something exciting that could improve surgical skills on a very significant scale. And that it does have quite a lot of challenges, but I believe that one of the next topics we'll be focusing on are specifically about challenges with integrating this technology. So I can save my thoughts on that when we get to that point.
Thank you. And, I notice sort of another common thread here. It's democratizing training, but I want to stay focused on that novice surgeon. Natalia, your story is exactly that. It's the novice surgeon who stands to benefit perhaps the most from the early development of this. And you mentioned a bit of that, Jacqueline. So I want to turn it over to you to hear a little bit more of your thoughts on this topic and how you've seen this work, especially within the context of the novice surgeon training programs you have.
Yes. So I agree with a lot of what's already been said. I think that really instruction is a huge part of getting people off the ground and started. And I from the years that I've kind of spent doing one-on-one trainings with the novice surgeon, I've really felt like starting off in that with a good instructor or good instruction, which could be done virtually, as Dr. Ferris has mentioned, but having some basic introduction to the technique gets you off on a good foot, and kind of gets you to start to develop those skills. And then I think a lot of the other practice, at that point can then be guided independently with some curriculum or some additional simulation practice. But I think having intermittent assessments then it really helps to kind of advance that progress that the novice surgeon can make through their independent practice. So I think that's all been really great comments made so far. Additionally, what Natalia was kind of saying is that it's the VR benefits, and one of the big things of that is the fact that it's very reproducible, and it allows repetitions in a very simple way, right? It doesn't take a lot to set it back up and do it again, right? And do that over and over. And I think you can make a lot of progress in a really short period of time because of that simplistic setup model and the ability to reproduce it without having to get another eye model out or use additional supplies. It allows for that really easy repetition. So I also think VR is very helpful in that training of the novice surgeon. One of the hurdles that we kind of came across, it was just time and access. And I think, we know that there's a benefit to simulation, and a lot of the trainees notice that there's a benefit to simulation too. And they want to practice and stuff, but they feel that sometimes time or access to supplies or a space to do it or equipment is kind of a limiting factor. Plus the time that it takes to even to set that up, that can be really overwhelming. Just the idea of I have to find all of these things and do those things, or set this up, set this machine up, or I have to find these eye models. And so that can be overwhelming, which is where I think VR is really helpful because it's kind of an easy setup. You can kind of, as Natalia said, the model that they're working with Orbis is kind of an off-the-shelf type of a thing, which can have transportability, allow for easy setup, and let somebody kind of practice in that way. But additionally, I think thinking outside the box about artificial eye models and how we can be using those, and then we can actually be using those artificial eye models in our own ORs, right? We can bring those into our surgical spaces and use those. And I think that really helps to reduce this access barrier, because you already have your supplies there, you have your equipment there. All you have to do is bring this really clean eye model in, and you simulate a surgery in your environment, which a lot of studies show that actually learning is most efficient when it's done in the environment which you're going to be needing to reproduce it. And so it's actually, I think, a great learning tool to also just be able to use your own OR. You don't need a special simulation space. You don't need a special wet lab to be able to use these eye models in kind of an area where it's your own environment and everything's readily available. You just have to find it in the shelves or in the drawers or wherever they are. So I think that's a really important piece to keep in mind, is that, sometimes the idea can be very overwhelming of the setup time and the space, but I think we can think outside the box and see how we can use those spaces to our advantage that we already have.
The immersive environment is really efficient.
Yeah.
The way to say it, to summarize that, that's really good.
Yeah, I completely agree, Jackie. And I think some of the arguments about cost as well. We don't have a wet lab, and we don't have a fake machine or a wet lab. You've got a wet lab that's called an operating theater.
Yeah.
So at the end of your theater list, bring the Model Eyes in, leave the phaco. You've just done the last case in setting it up, and you've got half an hour to spare. Put the Model Eyes down there. Your trainer's there. They can spare half an hour with you, and you've got your ready-made wet lab in the environment you're going to be operating in. Absolutely perfect, and such an important point to make, because many people don't have access to a wet lab, but they've got access to their operating theatre, and they just need to tell the team in theatre these are Model Eyes which can be brought in. You can't do it with pig's eyes, anything like that, but you can bring the Model Eyes in, and often the reusable ones, the Bionica are really good eyes, the Philips Studio ones, and you can practice what, if you've been lucky enough to have access to a virtual reality simulator, it's the next step. You've been using the IC or the fundamental VR, and you're taking the models in and you're using those models in your operating theatre, and then the next step is to live surgery. It's a really nice transition, and cheap and accessible to everyone.
But
Yeah, exactly.
But not no cost. And so, again, in terms of barriers, Jacqueline, you listed, portability, cost, time, availability of resources, and so on. All of these things are really significant challenges in improving skills training effectiveness, because the stuff to do that with. Oh, one other thing I didn't hear any of you mention that I would like to just address briefly, and we're at the end of this time for this question. Let me just to mention an important issue is how ready are the learners to learn? And one of the big challenges I found in working in I mentioned all these institutions that I've worked in so many different countries, and many of them with very poor medical infrastructure in place, but very willing and interested participants to improve their surgical skills. But what oftentimes I found is that the basic learning skills, what is it, we presume what it means, what it takes to learn something. We've grown up in an environment where that happens. Here's where I think one other piece of this technology advances can help us, and that is autonomous learning teaches not just a skill, but it teaches you how to learn the skill. So if you back up one step from just learning information to how do you learn that information, well-designed autonomous learning programs actually teach the learners how to learn. They're taking them through the steps of what it takes to learn. It develops interest, it finds areas where they're interested. And one of the questions in our Q&A box was about, what about AI? Cognitive AI can be a tremendous value, I think, in helping us learn how to train learners, improve not just how we present the information, but actually prepare all of us to receive that information better by finding those things where there's particular need, by identifying specific interests that we have and feeding into those things. That's what AI does. It sees those patterns in what we question and how we question it, and by doing so can really help us, I think, develop better autonomous learning systems that will actually help learners learn better. So that's the only other piece that I would add. Jason, I know Jason Pennycook, thank you for that question, and appreciate your interest in that. And I hope at some point we'll see further development of the AI components that are going to make simulation more efficient also. So what we're lacking right now, the development of all that is still in process. I want to get to the ask if you have any other final thoughts on this question before we go to the next one. John, to you, any last thoughts that you would want to add, summarize, or whatever?
Well, I think we're on a CyberSight webinar. I want to draw attention, to the amazing courses that CyberSight run to help people then prepare for hands-on surgical training, and they're in multiple languages, I think about 10 languages, and thousands of people around the globe have made use of those. So there's the fundamental phaco courses, small incision cataract surgery courses, which get then people the theoretical knowledge. There's another thing I'd like to mention for any listeners who have access to an Apple device, an iPhone or an iPad. You can download a free iBook called Phacoemulsification by Paul Sullivan. So Phacoemulsification, Paul Sullivan, and it's a wonderful free animated and beautifully illustrated book at every step of phacoemulsification. And all our UK trainees have to study that before they go on their mandatory training course. If you don't have an Apple device, there is a free PDF of that book. And I think it's absolutely brilliant resource. He's also got another one called The Open Globe for managing ocular trauma. So that the combination of the CyberSight courses, free resources like that. But the other important point to mention that surgery, really 20% is your manual dexterity and theoretical knowledge. 80% is what's going on inside your head. And having a good trainer and a mentor to help you just get in the mindset of a surgeon as you approach your first live surgery, when you've had your first complication, how to deal with that. That's something AI isn't going to help with. That has to be one-to-one mentoring, really important, because it's often surgical decision making rather than actually talent and hand-eye coordination. It's surgical decision making and how to deal with stressful situations, a really important aspect of your training. And this is where simulation, both on the virtual reality and the model eyes, can be really helpful, because you can put trainees in on comfortable positions, but perfectly safe ones. It still feels stressful to the trainee, and they have to deal with that. So one of the questions that's come up on the Q&A was, can we define affordable better? Some of the model eyes, it says here, not really affordable, and the ones which are affordable aren't very good. And I would say that both Bionico and Philips Studio, who in my opinion, both of those companies make the most high fidelity eyes, are very much working on developing cataract eyes, which can be used multiple times. The Capsular X's eye made by Philips Studio, I've just done courses in Barcelona in this, and one model eye, you can literally do 200 or 300 Capsular X's with a single model eye. So for $90, this is a model eye which you just need one of in your department, and you can do literally hundreds of Capsular X's on that model eye. And some of the reusable cataract ones, they are coming down in price and hopefully more accessible. But I think it's impossible to define what we mean by affordable, because it really depends on the healthcare system that you're working in.
Indeed.
Don't know if Jackie and Glenn, you've got any comments about affordability.
Yeah, Jackie, over to you. What do you think?
Yeah, I agree with exactly what you said, that making just a small investment, sometimes these eyes can really allow for multiple repetitions and allow you to practice that skill over and over again for just maybe a little cost. I think also when I think about cost and how can we reduce that, you want to be thinking about how can we reuse the things we already have, or how can we find maybe another model or something that's similar. And I think sometimes just even working on general tasks or more, not necessarily the specific surgical task that you want to be able to improve on, but even the general task can make a big difference. And so what I mean by that is, like, sometimes we'll say, if you're not really sure what you need to go and work on in the sim lab, or what you can work on, or what we have available for you, just even grabbing an eye model or something to suture on underneath a microscope with the instruments can make a huge difference. So just spending like an hour or 30 minutes under the microscope, just tying sutures, is going to improve your dexterity, is going to improve your ability to operate under the microscope, and improve both you're working with both hands and strengthening both hands. And so I guess to answer the question about cost, sometimes just using things that you have already had and just doing something else still is going to help your overall surgical ability. So for example, we'll use a Phillips eye. We'll have a cataract surgery and use one of the Phillips eyes, and that's really helpful. But then that eye's kind of done, except that we can make a bunch of wounds on it, right? So we can make wounds all the way around it, and then we can suture all those wounds. And so I've just done a bunch of different procedures on that one eye, and to be able to reuse it multiple times. And the skill wasn't lost. I didn't lose any skill with that. In fact, I gained a bunch of other skills by just being able to do that under the microscope. And I think, learning how to suture is going to improve everything, or, improve your skill overall, and improve your ability to adapt to new skills and learn new skills. Because it's impossible for us to teach you every single skill. You're going to have to always learn how to learn new skills. And I think just being able to have that adaptability can really make a big difference, I guess. And so that's, I think, a way to answer that affordability question.
Yeah,
I completely agree, Jackie. Yeah, the one of the questions was asked, and one of our listeners from Pakistan was saying they're using goat's eyes for strabismus, and the model animal material is quite good for that. But a single Philips Studio strabismus eye, my trainees have one of those. And the record so far, Rebecca Jones did 115 strabismus procedures on that one model eye. You just keep on doing recess, adjustables. And David Lockington, who's the incoming president of Eukiscris, he ran a competition last year for his trainees in Glasgow with the models you've just spoken about, the basic phaco eye. How many different operations can you do in that model eye? 38 was the record that won it. Oh, yeah. 38 different procedures having done a phaco. With trauma and corneal grafting and all sorts of things on that model eye. So 100%, you can get many hours of practice out of one model.
Very important points about the way to utilize resources like this efficiently. But I have a little bit of a bias in that a lot of the countries I worked in really didn't have access even to that. To just get one eye was a monumental undertaking. I particularly like Natalia's comment about the Orbis effort to make a really high quality tool available at no cost. It's not free, be sure of that, but to the user, it becomes something that is very low cost or free. So then it's the question of time and effort to integrate it into what they're doing. Second point that I would make is that this is about recoverable costs. So surgery costs a lot. You do surgery and you're using up stuff, all the time. Your time, nurses' time, disposables, and so on. And all those things have costs, but those costs are recoverable. The problem with training that I see globally, everywhere, is how do you recover the costs for doing the training, and these things that we're talking about, like model eyes, trying to find ways to make those costs recoverable for the institutions that are providing them, for individuals who are needing them. That's a bit of a challenge, I would say. So, John, you have an answer, I'm hoping.
I do have an answer, and we use this in the debate when people say, "Oh, it's very expensive." And Sarah Malling pointed out that she does a phaco list once a week 20 cases on an all-day list, all complexity. And her first-year trainee, who started 13 months ago, she's done 550 solo phacos, taking part on those, 10 cases a list, operating list. Well, normally we would have 6 or 7 on operating list for the trainee. She's doing 10. So she was saying to her institution, by providing the simulation with the IC and the model eyes beforehand, I have not had to cut a single case from my list. I just carry on with my normal list, and the trainee gets trained. And she did the costs, and actually it has made the hospital several £100,000 in a year with increased income from the cases she was doing, whereas her colleagues, reducing the number of cases being done, losing income. So increasing the number of cases on your list, doing more cases on the list than you normally would. That if you do an extra case on an operating list, that buys you enough model eyes for a whole year.
Love that answer.
Now, it works in different healthcare systems, and in different, again, in Africa and others, not getting paid per case. But if you can improve the efficiency of your training so that your lists are not reduced the number of cases you are doing, that very quickly pays for not only the model eyes, but probably a fair chunk of your virtual reality simulator over a year or two, as well as reducing complications. So that is a really good argument to put to managers and others. Say, well, we don't have the money. Well, if we're going to put more cases on a list and we're going to be quicker and more efficient at doing it, there's your answer.
Well, Natalia, could I come back to you? We really do need to end this question here, but I can't help it. I got to come back to you just one more time. You brought up the issue of providing the simulator at Orbis, the Orbis project to do that. There's a startup cost. In other words, John, what you're talking about is a result of having the equipment and being able to demonstrate over time its value. You recover it over time. But there is a startup cost, of course, and that then can itself become a barrier as well. Natalia, what are your thoughts? Any comments or thoughts about what you've seen or heard in being able to address the early costs, the startup costs in some of these countries, and being able to provide tools, to get the ball rolling, so then you can start recovering some of these things and expand. But how do you get the ball rolling? Maybe that's the question I'm after here. Natalia?
Yeah, so I think the biggest cost is associated with actually developing the virtual reality, and you always need to think about the impact versus effort, and find a balance and a sweet spot where the benefits of VR training justify the resources invested. But once you get the application out there, and especially in Orbis's case, I mean, they donate these simulators to low to middle income countries. So the users don't really have any costs associated with it. And in terms of just generally investing in VR and in other technology, I mean, these things are getting cheaper and cheaper. Even your Meta Quests a few years ago cost $1,000 or so per headset. Now we're down to $500. And so it's getting better. And I think also with VR development, I mean, as we progress and as we get new technology, these costs will start going down slowly. So it will be easier to create more and simulate more with smaller investments.
Do you see any open source tools coming down the pike?
Yeah, I think absolutely. So in Fundamental VR, we do have a platform called Fundamental Core, where you pay to access it, but you can, if you're an engineer, you can create your own simulation, and you can use little tools like SDK, so little elements. You can just pull it in. So you don't even need to be a really amazing engineer, a coder. If you have the basics of how you can create virtual reality, you can use tools like that and just create your own things and create your own learning tools. So we're starting to see an uptick in the usage of platforms like this, and people are really interested, and even people like self-learners can go and practice. And once again, the cost of having an account isn't that expensive, but what it gives you is a platform where you can build it and then you can distribute it. So that's very unique, and that's amazing.
So you can be a cataract surgeon and I could be a simulation engineer. Is that what you're saying? That with
Yeah,
this, with this,
absolutely.
okay,
Absolutely,
then
Dr. Strauss, you can go ahead and start building your own things.
I'll start building my own little baby here in the office. And there you go. Well, thank you all very much. And audience, thank you very much for your comments. And I know we weren't able to address everything that you have asked about. We'll try to get back to some of those as we get towards the end, but I do want to be sure and move along to our second question, which I think is very important for us to consider. The trainings we work in have well-developed practices, well-developed systems in place. And in some ways, if you mess with any of those systems, the wheels come off pretty easily. In our own institutions, trying to advance new ideas and new ways to do things in the learning arena sometimes can be quite challenging. Advances in what we do, like new techniques for phacoemulsification, for example, those are expected, anticipated, and are actually programmed into the system, for dealing with these advances. But we have to address, I think, at some point, the reality that the institutions, especially the larger ones, will tend to be late adopters, of some of these technologies we're talking about. And I'd like to hear what our panelists think about that. Let me ask the audience a quick question first. How many of you work in institutions that have limited IT infrastructure? If you could just raise your hands and let's get a quick look at that limited infrastructure question. That number is going up pretty quick. So it's a difficult problem. I remember and continue to answer, please. How many of you have limited access to IT infrastructure? When we were working with the team in Ethiopia, and half the time when I would try to get in touch with them or connect with them, the internet wasn't working, and so they really couldn't participate in the remote training process. So it's a problem. But the result of our learning these new techniques helps us move forward with surgical advances, but sometimes we get stuck in how to advance things within our bigger systems. One last question for our attendees. How many of you work in institutions that are upgrading or integrating simulation-based training right now? Very interesting question for us to see, I think, as panelists. How many of you are in an institution where you are upgrading or integrating simulation-based training right now? And by that, I mean computer simulation-based training. 6. Okay. So some, not a terribly high number, may not have been the best question because I don't know what the baseline is. How many of you already have simulation computer-based training? I don't know the answer to that, but at least it says that there's a that we're at the beginning of building momentum to change some of the systems that can do what we need to do to deliver better training. And that gets to my second question then. How do we overcome institutional barriers, institutional training inertia type things? How do we deal with that? What do you see are the key challenges? And really, panelists, what do you see as the key challenges in integrating technological advances into existing training programs? How do we overcome those challenges? Let me turn, Jackie, first to you. You've been involved in development of just that at your institution, I believe, fairly recently. So I think it'd be great to start with you and hear how you have survived. Perhaps is the right word. The politics, the money issues, the et cetera, that I'm sure go along with what you've been trying to do. So could you begin our discussion, please?
Yeah, I mean, the money issues is always challenging for the I guess computer-based training. There is a large cost that is upfront, and so we luckily were able to receive a donor for that. But I don't know that I can speak exactly about how to answer that solve that issue. But because I've been involved in how to implement this and get this involved into our trainees, and we got to feel that cost that we put into it. We got to get that used, right? We got to figure out a way, how can we use this to our best advantage, and how can we make sure that our residents are benefiting from it appropriately. I think there is one of the difficulties with, I think, virtual reality, even a little bit with the eye models too, and independent study, is that you can learn to beat the game a little bit. You can learn how to do something and not maybe do it exactly right. And so there's a part of me that I have to think about that, and like, how can we make sure that when we're having these novice train or beginning surgeons do independent practice, how often do we have to have assessments? How often do I need to be checking in? Should I be there all the time for the first, X amount of times they're down there? And actually integrating a lot of that technological advances is challenging from that regards, because I just can't always make sure from a time perspective that they're learning what I want them to learn. And sometimes I think when I've come across like the IC, for example, is what we use, and so I have most experience with that they start to focus so much on the score and of that computer independent kind of the artificial intelligence type of a assessment that they get, that they almost forget about what their hands should be doing, and like what's the right way to hold the instrument. And they can learn how to hold the instrument funny, or they do something different just so that they can beat the score, and without actually focusing on the actual correct way to operate. And so I've tried to almost encourage them to do on the IC, if you guys are familiar with that, there's these tasks where they're not surgically based. They're like, it's not the Rexus. We're not doing divide and conquer. We're not doing wounds or injecting an IOL. We're not doing an actual step of a surgery, but we're doing things like, how do we move in the eye? How do we keep the eye centered? How do we have our hands positioned? And so I think a lot of that focus then becomes on the correct way to do something, which then if you learn that basic stuff correctly, it allows you to, I think, advance skills more easily down the road when you need to, when new advances come, right? Or new surgical techniques come. If you have the right basics and you've done it correctly, and you're accurate, or you know exactly what you should be doing, it's easier to transfer those skills then to the newer techniques.
Mm-hmm. Great point. Don, you have your hand raised.
Yeah, I completely agree. We'll just go slightly technical to start with, Jackie. When our trainees are using the IC to do their capsular Rexus, they get scored poorly if the eye moves, operating without the right reflex. So they learn to game the system, as you say, by pressing down on the eye to anchor it. And of course, you press down on the human eye, all the viscoelastic comes out. They can't do the capsular Rexus. And the other really important point you made, I'm glad you made it, is that when you're looking down the microscope, all you're seeing is the eyeball. So Ivo Ferreira, amazing surgeon from Uruguay who runs the Ophthalmo University, has just posted 5 fantastic videos using Bionico eyes on the simulated ocular surgery gallery. And it not only has the microscope view, but he's got 2 cameras on his hands in a little cutouts at the bottom. So you can see the position of his hands, and he'll say, see how I'm changing the position of my hand? I'm doing this, I'm moving my chair. And so all of those nuance points are being taught in those videos of, it's not just what's going on in the eye, here's how to hold your hands, here's how to position things. Going on to the subject of affordability and accessibility, I've had the pleasure of running courses with Will Dean and the faculty of the Community Eye Health Institute in Cape Town. Now, Cape Town, as Glenn will know, is the only location on the continent of Africa that has an IC. And by raising the money from charitable donations, the IC is there. But what the Dion Menez and the team there do are bringing trainers, building faculty, and trainees from all over, not just sub-Saharan Africa, but elsewhere as well, to come to Cape Town to access the IC. So it's only one simulator, but they can spend a week there, and they do different types of courses, and you're training a faculty who will then go back and have been taught how to use the Model Eyes and the IC back to their units, who can then start doing the Model Eye training back to where they are. So one of the issues is getting buy-in from the institutions, to answer your original question, getting a dedicated team of trainers, which Jackie and I and others in the US and certainly the UK and Australia and other places already have. But you need to develop a team of trainers who are committed to this, who've been taught how to use the technology and the Model Eyes, and then to go back and say, well, this is the resources that we have, this is what we can do. One of the questions on the Q&A was, where can we find out more about the resources available? And I answered, if you go onto CyberSite, Orbis have a fantastic simulation center manual. It's about 80-page manual put together by Amelia Geary, and it's got everything from types of sutures, Model Eyes, how to build a dry lab of different sizes. So it's basically a toolkit to say, well, if you've got this resource, this is what you can have. If your resources are less or more, this is what you can have. And it's absolutely brilliant in helping people look at their budgets and go, well, I could provide this with this amount of funding. So buy-in from the faculty, trained faculty, and then using the resources in your country or continent, as it turns out in Africa, to the benefit for as many people as possible. And the same could be done, in Pakistan or Bangladesh, and the people listening in here. If you had just even one IC in the country, or one, if you're doing small incision cataract surgery, 2 or 3 of the fundamental VR ones, people can come and travel and attend the courses. So start small, and then you can build once you get buy-in from the trainers.
I love that. Start small and develop and build by. Don't wait for it, but start small and move forward. So just to summarize, Jackie, it's the initial cost, finding donors and so on. It's a critical part of healthcare development. Actually, it never starts. Big heart institutes have somebody's name on it, for goodness sakes. Why is that? Is because you can't recover the costs of startup very well. So that has to come from outside sources. Most often, that's where it comes from. But John, to your point, you government mandate, you've got to do simulation training. So one way to integrate something is, there's no choice. You will integrate this, period. And but then building with that the things that develop the real value of it once it's in the system. Now, how do we get the most value out of it? And a lot of the things you've spoken about have to do with increasing the value, reuse of equipment, of the Model Eyes, for example. You both talked about that. Ways that you can actually expand the value of the things that you have access to. Natalia, I'd like to hear just a little bit from you about what is your sense in talking to, so you also spend a lot of time at iMeetings. I know you do, talking to people from all over the world who are trying out these pieces of equipment, and thinking about whether or not they can have access to something like this. What are some of the most common problems that you hear when people they may try it, but there's what are you hearing from the people who are considering getting something like this?
I think VR, like with any technology, there's always a learning curve associated, and you're often met with some kind of resistance. from people who are accustomed to traditional training methods. Now, I think that we've all been in situations where we get a new fancy smart TV or some smart kitchen appliance that talks to you, and we've been trying to integrate it into our own life and had some kind of difficulties. So I think we can all kind of relate to this problem. But going back more specifically to VR simulations and some of the challenges that I've experienced. So first you start from getting the simulator even into the relevant organizations. And yes, they're portable and easily movable, but you have to think about custom laws and security issues on the borders. Then onboarding faculty and students on the simulator, you really have to have a set process and think about ways to do this in a very smart and efficient way. One thing that I think is very important is ensuring that the technology is used by the correct audience. So how you position the tool is incredibly important. If I put experienced surgeons on the fundamental VR simulator, they have to unlearn everything they know. And we're like, well, I do it this way, and there's a different technique, and it doesn't feel right. And I'm like, it's not supposed to. And this isn't for you. This is for your students, so that you don't need to go and teach them those ABCs that I was talking about previously, and so that you can save time, and they already know the basics of the procedure. So positioning is incredibly important. And then once you have your target users, they have to have appropriate technical support, because sometimes the computer wants to update, or the internet doesn't work, or something happens with the headset that you need to set it up again. And then support resources. So for Orbis, there is an online support portal with a variety of videos and how to set up the kit and how to go through the procedure. So we try to really think about how to enable the users to use the technology. And then also it's really important, I think we've touched on this, is how you integrate the technology not only within that individual organization, but also into some kind of curriculum or training program to ensure consistent training outcomes across these different partners. And then finally, incorporating methods to collect assessment and feedback. And how do we use this information to enhance and create improved versions of a simulator? And then you just go back to development and you can start this entire process all over again. So quite a lot of challenges here, but I think with careful planning, stakeholder engagement, ongoing support, definitely creativity and patience, and learning from experience, you can overcome a lot of these challenges.
Great answer. And I like the detail that you mentioned. A lot of that is behind the scenes stuff. And that has to happen for there to be adoption of new technologies. That partnership between the source of the technology and the recipient of the technology, a true partnership, is very helpful for things like that. And having companies that are willing to position themselves as partners, not as just, hey, we've got this, do you want it or not? Here's the stuff, you buy it, and then it's yours. If that happens in the early adopters period, it will fail, right? Because the early adopters need the hand-holding. Those are the people who need the partnership, especially. Once it's well established, momentum builds, then these things can pretty easily start to build on themselves. And people sort of know, oh yes, when I get in a car that has a button, I push the button and I don't turn the key. You know that finally, right? You didn't know that at first, but after a while, everybody kind of knows that's what happens. So I think it's somewhat the same with overcoming some of the inertia, educational inertia that we have. In general, I think people tend, there's still a bit of a divide, maybe a bit of a feeling that virtual reality training is more trouble than it's worth. The fidelity is not yet to that level. Even some of the very sophisticated simulators are still not at that level where you can truly fully immerse yourself in it and be completely autonomous as if you're in the operating room working on a patient. That level of simulation does not exist at this point. And so we're in that funny period where it's growing I liken it to that period when I'm old enough that I used one of the first Cavitrons that came out. I don't know if any of y'all had the privilege of using one of those, but man, it was a nightmare because the hydraulic controls were very sketchy. It was not an easy tool to use by any stretch, and I would say that there was every possibility that it may have failed. Just the Kelman phacoemulsification Cavitron unit, launched a new horizon for us, a new season for ophthalmology, no question about that. But the early stages were not pretty, and in some ways, simulation is sort of, I think, skills training in ophthalmology is sort of in that same boat right now. Having a lot of ugly babies that we're dealing with, that cost a lot, but maybe don't look as nice as they should or something like that. But still, everyone knows that this is the direction that it needs to go. So I think with time, there will be every reason to expect we will overcome the inertia that holds it back to some degree. John, you want to add something?
Yeah, no, one of the questions asked by Jason is on the chat was how to overcome resistance from more senior colleagues who, well, we didn't use this. I didn't. Jackie would. You and I didn't, Glenn, when we started. And they're saying the same conversation I've had over the last decade with some older UK surgeon. Well, I never needed that. I was a perfectly good surgeon. I don't know what their complications were when they were a junior. I suspect pretty high. But it was really fascinating during COVID, the number of some of my senior colleagues who would say, "Oh, that IC simulator," which they've never set eyes on before. Could I have a little go on the simulator, please? Could they've been out of theatre for 3 or 4 months and they'd maybe a private list of cataracts to go and do when they got back? They're feeling a bit rusty. I'd be delighted. Show them the code. Oh, this is quite good. Well, this is quite realistic, isn't it? And they'd spent quite a bit of time in the simulator, and suddenly they were much more sympathetic to colleagues who'd had a spell away from training, be it maybe doing a PhD or research or maternity or paternity leave. And you could see the sort of smile on their face when they were using it, going, this is quite realistic, really. So for those who are doubting it, I would say get your hands on some of the Model Eyes, get over to a simulator, be access to it, get them to try it. And especially if they've had a bit of a layoff. In the UK, I think it was a eureka moment for a lot of people who'd never used it in their training, but they felt just a bit anxious about going back after a 3 or 4 month break. These are people who've done tens of thousands of phacos, and they just weren't very happy about going straight back into an OR after that big long layoff. Okay, after a 2 or 3 week holiday, 3 or 4 months, they would think, well, maybe I'll just use the simulator. And good on them for having the courage to ask and to do it. And that convinced a lot of them that actually is a good thing. And if I had that as a trainee, I would probably have progressed more quickly. So get them to try it, Jason, or the Model Eyes, and then they can speak from a position of having a practical experience. At the minute,
we had a very similar experience where we, during COVID, brought the artificial eyes into the OR, and our more senior faculty felt more comfortable with it, and realizing what great tools and thinking about ways how they can then use them, right? And how they can encourage or use them in their practice with residents. So when our ORs were down, just being able to bring those eyes into our OR and then having them available to people to try, I think that started to really build a knowledge and understanding. And then curriculum started to be developed. I mean, it was kind of a fun, productive sessions to have.
Yeah, in a very not fun time.
Exactly. Yeah.
Some good things came out. Absolutely. So great discussion. I hate to cut this off actually, but we've got about 15 minutes left. It's not a hard stop, but I do want to respect everyone's time, and I would like to get to our last point. And I think it flows nicely from what we're talking about now, in that at some point you have to start asking, is it really valuable? Does it really work in an objective sort of answer to that? Can we give objective answers to the question of how does this work? John, you mentioned that in your introductory comments, some of the data that's come about that suggests if I don't know if proves, but at least strongly suggests that there's value to simulation-based training as a prelude for the novice surgeons before they go to live surgery. Reduces complications, improves the time factor, reduces the time that they take. All those factors are well documented now, especially for the IC, which had a big network. Lots of data was gathered about the use of that simulator over a long period of time. And so there's some good things that have come from that. But there's the question of predictive validity. And you know what I mean by that. It's that thing that says, we know that if we use this, we can predict this is what this surgeon is going to do. And we don't quite, I would say, at least to my knowledge, we don't quite have that level of validation yet for simulation. So we're getting there, but I wanted to ask you each, now in our last round of discussion here, what do you think we need to do to make our case objectively that surgical training, technology in surgical skills training can really be advanced by the use of simulation, particularly virtual reality simulation? And if so, how do we know what type of simulation is really needed? This goes back to your point earlier, Jackie, that there's just the mechanics of surgery, just suturing. What if we had a simulator that just did extraordinarily good, simulation of surgery and nothing else? Would that be enough? Your point was that no, maybe it might actually do a world of good. So how sophisticated the simulators need to be. I love working with the Orbis team on this question. It was a constant struggle. Can we raise the fidelity? Well, yes, but then we can't use this, then we can't do that. So the objective all along was, where's the most bang for the buck, so to speak, in terms of computational power, in terms of the ability to actually produce meaningful mechanical skills training in a relatively stable, low-cost simulation environment. That was the objective that I worked with them on. So over to you guys to hear a little bit more about this. John, let me start with you for this one. Again, we've got about 10, 15 minutes to...
Okay, we'll try and keep it brief. There are quite a few studies looking at predictive validity, face construct validity, but also predictive validity of both model eyes and the IC. For example, going on from your scores on the IC for capsular access and then scoring your first live capsular access. So evidence does exist. And I go back to Will's studies, the randomized control trials that showed the threefold improvement in competence and doubling of confidence and 75% reduction in complications. And this was just with the simple model eyes. And those stats are there from randomized control trials. So it doesn't have to be the expensive virtual reality simulator, because most people listening into this today, only 20% have access to that. So 80% of people don't. But those 80% of people can have access to the model eyes, which they can take into theater and use and follow the using the scoring algorithms that are freely available, showing this is how you would score people's competence. And as a first step, people can start using those and reusing those eyes to develop their skills for small incision cataract surgery. And I think that would maybe a good place to start, because trying to leap in and buy an IC, develop a phacoemulsification training program, probably going to be a step too far initially for a lot of the people listening today. So look at the Orbis simulation manual, read the papers, the Olympics and the GLASS study by Will Dean. Just put those into Google and you'll see exactly what they did. And then the low-tech setup that they have in Cape Town with little STEMI, Zeiss STEMI microscopes, very portable. All you need is one of those. So I would suggest you could probably set up a small incision cataract surgery training for under $3,000. That's the equipment that you would need to set up a system for teaching that. And when the fundamental VR comes online, becomes available, what a great adjuvant to have as well to complement that technology. And I know Orbis and Fundamental VR are working very hard to do that. That's the next step. But if you want to get up and running straight away, read those studies, use the Orbis handbook, and the kit is there. All you need is literally a room and a little portable microscope, and you're ready to go.
Brilliant. Thank you, John. Jackie, over to you.
Yeah, I think finding like what is it that what do we need to do? What's our base? And I the comments I made earlier about just improving the dexterity, improving our surgical base can really help us then expand down the road, I think is where a lot of my thought processes lie. And an example of this is like let's say if we can learn or teach a scleral flap, or how to make a scleral flap, or how to make a scleral wound, that can be extrapolated to multiple surgeries. I mean, we're talking about that can be used in a trab surgery or a glued IOL technique for the scleral fixation using glued IOL, or even scleral windows, or then we can apply that to extra caps and M6 and stuff. And so like having a basic skill set can really help us apply to more challenging things or do more challenging things. So again, I think focusing on really just a few basic things, if we can just focus on how do we suture and improving that under the microscope, or focusing on rhexis and improving that and working on that, and not necessarily expanding to really complex surgeries, but focusing on the basics of the surgery could really help, I think, expand our training overall. And I love Dr. Ferris's comment earlier about 20% of it is dexterity and 80% of it is knowledge or in the head. And I think that's actually really true. I think understanding the surgical technique is really, and watching videos and learning about it in a curriculum standpoint and getting it in your head and understanding the knowledge of that is really a big part of surgery. And then having the basics that we build upon, the dexterity and learning that is a small part, but we have foundation blocks that we build on in order to help kind of advance that surgical technique.
How do we validate what are the basic skills? So for you like you said, suturing, well, that's a basic skill, but what about that is a basic skill? So I have in my head sort of an idea of what not basic skills, but basic mechanics. And the mechanics have to do with how the surgeon uses their fingertips, rolling their hands, tilting their wrists, how they position their arm in space, how they position their body. There's mechanics, and everybody's mechanics are like a fingerprint. I can tell that surgeon watching under the microscope through a video that was Surgeon X if I've worked with them before, because it is so characteristic of how they do things. Because it's observable, to me, it's measurable. And if it's measurable, that means we could possibly use it as a way to develop some of the validation processes, some of the validation that needs to be done to really understand what are the basic skills that an ophthalmologist needs. I don't know that question has been specifically answered, but to me, that would be one of the challenges for this generation to consider is what really are the basic mechanical skills and how do we best validate those? Second point I'd like to quickly make is just that I agree with your comment about the skills in the head, but I would add heart as one other component. And you actually said that, John. You really did. You included it in the head, but it's that problem of what do you do when things go wrong? Do you maintain your cool or don't you? And to me, that's an emotional maturity issue or an attitude that surgeons need to develop with time, and it's honed with time and with good reinforcement. That can become a strength that surgeons have. If it gets the wrong kind of reinforcement, it becomes a very negative thing, and people get frantic. You probably have seen that happen too. Things start to go wrong, and it just gets worse. And that's a sign, that maybe their head's working, maybe their skills are there, but their attitude or their heart isn't working so good. So I would just add that as an additional thought about that whole picture.
Yeah. That's
Yeah,
a great
and
point.
Glenn, that's a nice point to maybe finish on. David Lockington popularized something called the fire drill, again, in your theatre with the model eyes, and all your theatre team, your scrub team said, right, PC rupture, zonular dialysis, what are you going to do? And then you have to deal with it, and you talk to the patient, the model eyes, if it's a real patient, and you practice the tone of your voice, the instructions you're giving, staying calm, everybody knowing what their job is, like the Formula One team changing the wheels in the car.
Yeah.
They all know what their job is. Somebody will get the triamcinolone, somebody getting the suture in case there's an expulsive, and the whole team are simulating a complication, and they're talking to the patient, and they're doing it in the calm way. So when it happens in real life, and an uneducated, a non-medical observer would think the case was going perfectly. It was just taking a bit longer because nobody was shouting, nobody was getting panicky. And the patient who's awake has a nice experience because all they hear is just a little bit of extra chat going on. And low-tech simulation can do all that. And it's not just for the trainee. I think pilots train every year for 20 hours a year, mandated, no matter if they'd spent 30 years in the air. We should be thinking about senior surgeons and their team once a year, once every 6 months, just running through some scenarios that happen very rarely, and just making sure the entire team, not just the surgeon, are up to managing that complication. And low-tech simulation in your own OR does that really well. You can be the best surgeon in the world, but if the scrub nurse is panicking and nobody knows where the extra bits of equipment are, then it's not going to be a good outcome. So really simple simulation, more getting people's minds and headspace. And if you're calm as a surgeon, everybody else is calm around you. That he or she isn't panicking. Well, that's okay. Let's just carry on as normal. And everybody can do that listening in their theatre, with some cheap model eyes, for the type of surgery they like to do, and just practice rare complications to make sure the team is functioning really well, something that Orbis puts a great deal of emphasis on in their training.
Yes, indeed. I love that. And I've done that very thing, and that has made a world of difference when working in difficult environments. So I do an orientation with the operating room team from another hospital that I've not worked before. Here's what's going to happen. We don't know where there might be a complication, but here's 4 complications that I want us to be prepared for. And we'll do exactly that. And it's made such a difference. And it builds a camaraderie. It builds a positive view towards what we're doing this for in the first place. It's for the patient's benefit. No one's being judged. No one's being criticized. Everybody's part of the team. And that's such an important part of this, I would say. We might also refer, one of our attendees mentioned how valuable this can be for non-ophthalmologists, like optometrists. The optometric world can really benefit from observation and participation in that. I've had some great relationships over the years with people who are involved in doing post-op care, pre-op care, and understand better how to manage that once they participated in seeing how the surgery works and what it's all about. So, Natalia, let me just make a round of last thoughts and comments. Again, so much more we could talk about with this. I'd love the discussion. Let me just make a round with everyone to share their final thoughts or observations about any of the things we've talked about today. Natalia, you go first.
Thank you, Dr. Strauss. Yes, there's one tiny little thing that I'm really passionate about: data, right? And I think VR is really, really amazing and exciting in that it collects so much data. And as you go with time, you also get a lot of users and residents, and then one day you can use that data to perhaps evaluate some long-term outcomes and get really valuable insights into the effectiveness of these training advances. And also, I think I would really love for us at some point to look at all this data and use it to improve the simulation. This is kind of what we're already doing, but also how can the trainers use that data to learn more about their students and know what their pain points are, what they're really struggling with, and what areas to focus on. So yeah, I think this is very unique with simulations, is that they're offering just all of this data that can be utilized in so many ways.
Yeah, great point. Jackie, over to you. Final thoughts or comments?
Well, I just want to say I had a wonderful time discussing this today, and so I really appreciate the invite to participate in this webinar today. And it's been it's also fun and exciting time with simulation and learning all the advancements and how we can best teach our residents to uh, become great surgeons and become safe surgeons and really help improve our patient care. And so that's kind of my final comment. It's just been an exciting time.
Yeah, thank you. Thank you. John, over to you.
Yeah, again, thanks, Glenn, for putting this together. It's been great fun sharing the platform with everybody. A couple of simple messages. It doesn't have to be high tech. It doesn't have to be expensive. And getting engagement with your colleagues and just to see the trainees, the smile on their faces when they start to do things. Will tells a lovely story. His first trainee, she was first year a resident from Uganda. She'd done the M6 course and she went back, and only third years get taught how to do surgery in Uganda. And he had a phone call from his friend who was supervising her and said, she was amazing. She did all of the first case. Well, she got halfway through and I stopped her. Well, why did you stop? She said, it was going too well. It couldn't keep on going this well. He said, well, tomorrow, let her finish the whole case. Okay. So the next day, of course, she finished the whole case. And all the third years who'd never had access to simulation, how could this first year resident just whiz through her first ever live surgery, start to finish, did it perfectly? And that's what we need to get that message out there, that simple, very cheap simulation using these model eyes, can just transform the learning curve of young trainees who get to operate quickly and safer and without having the stress that we all had who didn't have simulation to start with. It's a must, really.
Great story. Great story. I think I met her actually when I was.
You might well have done.
Well, she's a wonderful lady. So, but yeah, great illustration of the point. And may I also add that it also does start. It's to your point earlier. Starting simple. There's nothing wrong with starting. In fact, that's the way to go. In all of the things we've talked about today, if you start with some very basic things, and there can be significant improvements just from small things. You don't need to go to the end, the final thing to get the latest, greatest for whatever. But do start simple and do take advantage of things that are available. The things that Orbis is offering, the Orbis simulation tools that are now coming out, CyberSight, and so on. These are great tools that anyone can have access to by design. That's what they're there for. That's what people can have access to. So I would encourage everyone towards that. Thank you, audience, for your participation today. Appreciate all your comments. Sorry we weren't able to get back to all of the questions, but I appreciate everything that everyone has contributed today. Special thanks to our panel. Loved getting to know you guys a little bit better and to hear some of your thoughts and comments about all this. And I think that will wrap it up. Thank you all very much. I believe they will close out the program for us then.
Thanks, you.
Ben. Bye now.
Thank you.
Thanks to everyone.